said, I'm Brett Asker, Senior Solution Architect here at Carbon Relay. So today we're here to talk about getting started with AI-driven Kubernetes optimization. I'm going to give you a little background just so you kind of understand the space and the kind of things that we do, and then we'll get into an actual demonstration. So starting off with our product, Red Skyopt. Red Skyopt platform uses machine learning to automatically optimize your Kubernetes application. That's not off-the-shelf Kubernetes applications. That's not sample applications. It's whatever your applications are doing. And that's important because you can optimize your exact solution. And that is important for doing things like ensuring SLAs, providing the tools for developers and engineers to be more efficient and productive in what they're doing, and ultimately to maximize capacity utilization. Capacity utilization is a challenge in the Kubernetes space. A lot of people are very over-provisioned in a lot of areas, and that can become more difficult because you're operating at larger scale, sometimes just because everything's over-provisioned. A little background on Carbon Relay, founded in 2016, and recently had an investment from Insight Partners back in February. And we've got a great leadership team here. Part of the reason I'm here is this team that you see here is really important for us to scale this company, right? And that's really where we are right now, is in scaling the company. Give you a little idea of why that investment was made. And it was really made by Mike Triplett at Insight Partners. He's very successful in this space. You see the companies on the left-hand side. These are the kind of companies that he's been responsible for bringing in to Insight Partners and going through that process. And the quote from him here is very important. And it's really about the world-class machine learning and engineering experts bringing to market an innovative solution to challenge Kubernetes complexity. That's the reason I'm here. That's the reason I joined the company as well. So what does Red Skyopt do? One of the things that we talk about, and it's really about automating the process of continuous Kubernetes optimization, is optimization by design. Why that's important is that you really should be able to optimize your applications. And as your applications change, you can also continue to optimize those applications. As you make changes to your application, they may need to be optimized in different ways. Ultimately, it's about allowing for better performance, better productivity, better return on investment. So the problem, Kubernetes configuration can be extremely complex. Kubernetes configuration, there's a lot of benefits to Kubernetes, right? So it's flexible, it's portable, it's cost effective, but with all of this, there's also some challenges. There's a steep learning curve for running Kubernetes and putting applications on Kubernetes that perform well. Ultimately, you want to be out of the business of really managing much at the Kubernetes layer because it's all about the applications. But a lot of times it's a lot of work to reliably deploy your applications. Part of that challenge is that there's numerous correlated parameters that make it impossible to tune applications efficiently. And the challenge is ultimately why we got into this. So our company did a classic pivot as a company because we were moving our AI and ML solutions off of Docker Swarm onto Kubernetes ourselves. And when we did that, we actually ran into some serious challenges in trying to get all the tuning the way that we wanted to. With that complexity, it just becomes a very hard problem. But because we're in this space, the light bulb came on and said, this is exactly what AI and ML are designed for. And that's why we did it to help ourselves. And then we said, this actually is a big problem for a lot of people. And this is what we want to go and tackle. We find optimal Kubernetes configurations with Red Skyopt. It's your application, and ultimately you want to be able to boost the performance of that application. We actually do that through an optimization experiment. So we take and run in down-level environments, experiments on your code to flesh out how that code behaves under pressure, under load, so that we can give you the optimal configurations for your application. And that helps you slash infrastructure and resource costs, and it actually allows you to maximize resource utilization. As we talked about, things tend to be over-provisioned, and that helps you maximize. And ultimately, it's for boosting your efficiency in your DevOps team and really allow your DevOps team to move on to higher value business kinds of functions, as opposed to driving just the technical functions around trying to optimize the applications. So I'm going to talk to you a little bit about how we can get started, because we now have a free trial tier. And so I'm going to show you how to get signed up for that. And at the end, I'll give you the links for being able to do that. So typical sign up process, you visit the sign up page, use either your GitHub, your Google or your email-based registration and sign up. If you choose email, you got to click on the verification link in the confirmation email, just like any other kind of app. You'll get a landing page like this. At one point, it'll say, we're provisioning your tenant. We're provisioning all the back-end AI and ML pieces for doing what we do on the back end for this experiment cycle. But when it's done, you'll see something like this. It says your service is now ready for use. And then it gives you 3 boxes here. And I'm actually going to walk you through what it looks like to follow the guide and to walk through your first experiment. And that's why I want to demonstrate today. So let's go ahead and go there. So here you would get in after you clicked on the page that will give you the follow the guide. This is the guide that you go to. And this is a quick start. So in here, it will describe how you can get logged in. I'm already logged in, so we're going to go beyond that. And then ultimately to initialize in your command. So we have a command line called Red Skyopt. Everybody's got a CTL in the Kubernetes space. Once you do that, you log in. That connects what's going to happen in your environment back to the machine learning in the back end. Once you do that, you'll run Red Skyopt init. It takes about 30 seconds for us to put all the pieces in a Red Sky namespace that will run the controller in there. And then when you're done with that, you can actually run Red Sky controller. Let me bring my terminal in here so that we can see this. Let me shrink my window down a little bit so we can see it a little bit better. Okay, so here I'm going to do a control check. I don't have a typo there. And you'll see a success message. So from there, you can move on to the next step. And this is creating an experiment. So I'm going to do this in a slightly different way, just simply because I'm doing it in a slightly different environment. But this allows you to run Kustomize. That's one of the things that you have to install as a prerequisite. Kustomize is part of Kubernetes, but you're not necessarily always running that locally. Kustomize is what allows us to inject different parameters so that in the experiment loop, you can actually execute. So I'm going to come here and I'm going to kick off one of these experiments. Slightly different than what's in the guide, but here I'm going to kick off an experiment testing a Postgres service and start doing the experiment. I'm going to show you what's going on in the background as we do this experiment. Here we will be able to, let me move these controls at the top of my page here that are interfering with my tabs. Ultimately, what you're seeing in the background is an experiment. So an experiment is an experiment file. And then what's going on in the experiment is we test against your application with a load test. The way it works is on your system, you just do the step that I did, reconcile the experiment to kick it off. It creates the experiment in the hosted part in our ML. We store that you're trying to do this experiment, and we'll show you the components of the experiments. Once that's happened, the cluster requests from the ML, what should I use as my parameters for my testing? So, and it comes back and suggests some parameters. Those parameters are suggested by the ML. Right now, at the first stage, we don't know anything about your application. So we're going to give some parameters to test. We're going to create a trial. It'll set it up, patch those resources so it has the settings that we're using, and then we're going to wait for the application to stabilize. Once the application stabilizes, which means it comes up, or it doesn't come up. It could be that it fails to come up, and we'll also capture that. It will come up, and then we will run a trial. When the trial's done, we'll collect the metrics we're interested in, And then ultimately we will report back that the trial finished and what those results were, so that we can again request assignments, and the machine learning gives us another set of parameters to test so that it can zero in on the best configurations for you. When it's done, you'll actually, and it will also clean up the test that was running before. So that's kind of the flow of what's going on in there. I'm going to kick back to my terminal here and show you how you can see the results of what's going on. So here, I'm going to show you the UI interface to show you what we see from the experiments. This case, this is the one I ran here for the webinar. This is the Postgres example. And I'm going to show you that we're testing cost and duration as our metrics, and we're running trials. So far, 3 of them have run, 2 have completed, and 1 was unstable. Unstable is an important piece of information because then you know that that configuration is not good for what you're doing. And for the 2 that have completed, we've got some dots already posting on here. As we go through, there'll be more and more of these that are running in the background. And ultimately, you'll end up with something that looks like this, which shows you all the trials and what are ultimately going to be the best configurations for what you're doing. I'll show you a little bit about in the code about what's going on. So what does an experiment look like? Well, an experiment looks like pretty much everything else in Kubernetes. It's a Kubernetes custom resource definition, a CRD. And in here, we're saying, what's the name of this experiment? And we saw that in the UI. How many trials I want to run. So I give it a budget. When you're first learning about your application, you probably want to try a lot more. We learn about your application as it goes, but when you first start out, you actually want to be able to do a larger number to find out better settings. What is it we're testing in this specific experiment? We're testing memory and CPU is what we're testing. And the metrics is how long does it take to run this job? So in this case, there's a job that's running PG Bench, a standard Postgres benchmarking tool to shove a bunch of data into Postgres to see how the application behaves. And we want to know the duration of it, and we want to know the cost of it. And the cost is based on a particular cost in the environment I'm running in, the cost of the CPU and memory on my nodes to run in that environment. In this case, it happens to be a GKE node of a certain size. And that will tell me a cost as a stand-in for how expensive is one of these runs compared to another. Ultimately, you know, the real cost of the application is based on a lot of other things, including discounts and you know, how things are going. This is specifically just so that you can do a comparison one to the other in there. Ultimately, we're going to patch the deployment so that everywhere in the deployment, we can inject the values that we want to inject. And then below this just says, how are we trialing this? This is another containerized application. And in this case, it's running PG Bench. And in there, there's a secret that we pass that says, here's the password and stuff for the database so that you can hit the database securely. This is important because ultimately what you're really doing is you're testing your application. And looking at your application, this is a standard YAML that you have for deploying something like Postgres. And in there, your developers or yourself, if you're one of those developers, has to do things like resource limits and requests. And in there, you start out with baselines. Problem is most of the examples that you find out there are kind of lowest common denominator. They give it to you in such a way that they're pretty sure it's going to run on everybody's system. That doesn't mean it's optimized for your application. It's just a starting point. And then you're supposed to figure out which one of these parameters you need to change in which way. Does it need to go up or down? Which one needs to go up? Which one needs to go down? Depends on what it is that you want to be able to do ultimately. And this is where the experiment comes in and says, hey, in that place where those numbers are hard-coded, let's change these values so that every trial can have a unique set of values so that we can see what the effect of those changes are. This is what one of these experiments looks like. So let me go back to our browser. Let's go look and see how many more trials have run. So 7 have completed in the background. 7 trials have been attempted. 6 have completed and 1 was unstable. We're starting to get more points on the graph. As the machine learning does this, it starts getting better understanding of what's going on. to the machine learning, this is basically a black box. Your application is a black box. We're trying to figure out how your application behaves. One of the powerful things about the ML and AI solution that we have is that it's specifically designed for this problem, but all these parameters and things that are being passed, the machine learning doesn't actually know whether that's a number of replicas, it's amount of memory, any of the settings that you might change. It doesn't even know what that is. Give you an idea of the kinds of things that we can do. You can jump in. Let me go to our GitHub page. And we have recipes for these kinds of applications. And these are the things that you would walk through in the guide. The one that you would walk through is this Postgres one, where we give you this exact thing so that you can run. In fact, we normally recommend that this is the one you run to make sure everything's configured okay. And then you can actually see it run in the background. As it's running in the background, by the way, if you're in your Kubernetes environment, let me turn off the results page here. And you want to do something like, okay, Kubernetes get trials, kubectl get trials. I'll actually show you what's running in the background. These are normal objects in Kubernetes, or CRDs. So you can do that. You can also get the experiments that you have in your environment. And it'll show you this experiment and the fact that it's running. So as it's going along, you can keep track of what's going on so that when it's done, you can look at the results when you're done. So that kind of gives you the idea of what it looks like to go through one of these things. Give you other kinds of examples as you talk about more complex. Right now, I'm just trying to show you how I get set up, but I want you to get an idea of what's out there in our recipes. There are all sorts of things. You might be running something like Elasticsearch in your environment, and there's a lot of configuration parameters. To get an idea of what's going on, we can look at the experiment and say, what are we testing here in this area? So in this case, we've got things like data memory, CPU, the number of replicas, the data heap percentage, client memory, and client CPU. This is a multi-piece, multi-component application. Each one of them needs to be part of the solution. You need to be able to figure out how these interact with each other, and so that you can change those. Again, the same kind of thing where we're measuring, and then ultimately what it is that we're trying to do, including passing parameters. You might have a complex Java application. Java applications have things that you tune, things like the stack and the memory values and the heap percentages and all of these things that you need to do for tuning the actual application, not just tuning Kubernetes parameters, all the way down to anything that can be exposed in your application. And that way you can tune for all the things, doing all of the things that you can do in your application to tune it for each piece of your application so that you come up with an optimal solution for what you're ultimately going after. So lots of examples here in our recipes for you to go through and just look at them. Some of them, like the voting app, this is the classic voting app from Docker that does the pet voting. So it's cats versus dog, very common application that people will use as an example. And it has an architecture that looks like this. And we test all tiers of that architecture to ultimately give you those answers. So if I go back and go after the results, let's see where we are in our results. So now we've completed 17 trials in the background. Now we're starting to get a better idea of where things are and where things go. In this UI, there's several things that you also get, and I'll give you one with a little bit more data in it. So this is a Postgres example. I've already run this one, so I'm showing you the cake after it's baked. Here I can filter down to the best, because ultimately you don't care about all the ones that aren't the best. You care about the ones that are, and that gives you the Pareto front of what are the best based on whatever axes you choose. In this case, it's cost versus duration. These axes can be anything that you want to define and based on the metrics that you want to collect. If throughput's important to you, use throughput as one of those measurements, latency of your application, whatever it is that's important for what you're doing. Usually once you get this kind of information, you can then say things like, let me click on one of these and see what were the parameters that were used. So this one has a cost of 48 and a duration of 5. And if I scroll down, here's the parameters I was using to get that measurement. Now, here's another one. Duration was just a little bit longer, but that cost was less than half the cost. How is that possible? Well, by making slight changes, it actually needed less CPU, it actually needed more memory to run this application. That's an important thing to know. And that ultimately, usually people will pick something kind of in the curve, in the sweet spot, balancing cost or duration. If throughput or duration is your most important thing, you may still choose this one. And it's good to know that. But you're going to find out what the optimal configuration looks like. As you get on working with your applications ultimately you're going to end up with more and more of more complex applications. In some cases, like this voting web app, literally the results were all over the page. We had 200 trials, 200 of which completed. So to me, that says we gave it some pretty sane results for what you're testing, because ultimately it's about those settings that you had in the recipes for what it is you're doing in your experiment file. Because as we test, we're testing these values, and this is the minimum and maximum value. Maybe we should have had minimums that were much smaller because we need to test less of something. And we always recommend use wider parameters when you're first testing to really understand your application. Ultimately, what you'll end up with is your results. But one of the nice things in our interface is not only do we give you the best, and we always give you the best, so you can figure out, but what is going on here? We're testing throughput. Well, maybe your throughput SLA is 100,000. So maybe you're going to pick some point here that gives you above 100,000, gives you a little bit of cushion. You might want to look and see what were the things that made up those set of settings so that you can understand how your application needs to be configured for the optimal result. You'll notice whenever you click on one of these, it's highlighted and the dot's a little bit bigger. That's the one we're showing the parameters down below. One of the more important things to me is actually understanding your application is parameter drill down. You want to understand things like, if I'm interested in throughput, how do each one of these parameters behave? Let's say for the database CPU. Okay, for the database CPU, which is one of these parameters down here, they tend to be clustered here, and then they kind of go up a little bit. But then what about this? This application has a bunch of replicas. So I'm going to look at the voting replicas. This is important to understand. For voting replicas, if I'm going to a certain level of throughput, one replica will only give me this level of performance. It doesn't go above that. I actually have to jump over here to 2 replicas to get higher performance, and then 3 replicas to go even higher, right? We may want to change the number of replicas in our test. Maybe we want to test a little wider depending on what it is that we're testing. Conversely, other replicas, like the worker in this environment, it's not always a straight line. It may be that one replica can give me a certain level of throughput, and then this one that we chose is over here with 2 replicas for this component. But then there's other ones that you can choose that might be better. Now, if I click on one of these and go back to my results, I'll find that it was more expensive, right? So the cost was a little higher on that. That's why when I chose on this graph, the dot changed. But that allows you to go back and forth and kind of determine where you are with what you've got going on. So let's go back to the UI and let's see here for the Postgres example in the webinar. So with 25 of the trials, we're starting to get closer to what this one that's completed looks like. Each time you run it, it's going to be a little bit different because the machine learning gets smarter and smarter about what's going on. So it's going to zero in faster and faster to the best configurations. And again, this is anything that you want to test and any kind of application that you want to test. Let me go back here and go back into my presentation. So the free tier gives you several things: the ability to run an optimized application in production. This is for life. So when you sign up, you get this community support, up to 2 metrics per experiment, up to 5 parameters per experiment, and 3 experiments per month. Like everything else, we've got multiple tiers, and we really want to work with you and work on the kinds of things that are going to make a difference for you. Let me move my slide back up here so it's on the page. And each one of those then starts unlocking different things, more metrics per experiment, more parameters per experiment. This is what you get for free. here's ultimately where we're going to get to. As you're tuning all these parameters, when it's just a couple of parameters, you can kind of create a grid, you can kind of do your testing and get you tested in kind of in a way. It's going to be a little brute force. You're going to do a lot more experiments than what our machine learning will do to get you the optimal configuration. Machine learning is better than humans at complex correlations. One of the things humans tend to do is when they're testing things, that they'll move something to where something that doesn't break and then something else breaks, and then they move that value up and then keep moving values up, but they don't tend to bring values down or understand those complex correlations. So I'm sure some of you have experienced where you change some settings and then it breaks something else. Like every time you change something, something else breaks. So people end up getting to the point where it's like, all right, nothing's broken, so nobody change anything. But you don't get your optimal configuration that way. You just get to a configuration, but it may be totally misconfigured to give you the best what you're doing. We efficiently explore the parameter space. That's what machine learning does. That's what we've optimized this machine learning to do, right? To get you to that, to find those complex correlations. And we do it through actual experimenting, which is very important, because then it's your app under its kind of load, whatever load you're running against it, to give you those right parameters. And it's problem agnostic. We don't require any domain expertise or upfront data. A lot of machine learning algorithms require a lot of data. They want 2 months of your running production data before they can really ingest and start doing this. We don't have any data about what it is that you're doing. Machine learning is immediately available, and because of the way that we test and because of the efficiency of this algorithm, we don't have to have all that upfront data. Now, we do get smarter the longer we go. I mean, that's what machine learning does, but we don't need it to be able to do that upfront. Key differentiator for us, it's powered by machine learning. It's not a tacked on thing. It's not a architecture thing. It's not, we threw a buzzword in there. We've actually got, the PhDs that work in this space, right? That have the degrees in mathematics and artificial intelligence and machine learning, respected folks in this space. It optimizes the application layer. There's a lot of other things out there trying to optimize just the Kubernetes parameters, right? But that doesn't get you all the way down into your application. Also, just proactively boost application performance. You want to know, what is the proper configuration going in? Maybe this is a net new application. I don't even know what the performance is supposed to be. I'm not even sure what it's capable of. You want that upfront information so that you know how to size your application and how to go into production with the right application. And more importantly, long-term in continuous optimization, you want to know, as you're making changes to your application and you're releasing a new release, you want to run the optimization again. If the optimization comes back with different numbers, maybe something about the application changed. It could be that you added 10% more functionality, and I expect it to be 10 or 15% different in the way that it behaves. But maybe that release was all about changing the branding. You were just changing colors from red to blue, and you were changing things under the covers that shouldn't have had any kind of impact on performance. But you run the optimization and you find out it's 25% less throughput, or whatever it is that you're measuring. You're going to want to know why. That's the value of a CI/CD pipeline, is sooner when something's broken. This also applies to optimization. It's now not performing well. What happened? Maybe there was a CVE and somebody upgraded a library under the covers because it was time to patch. They patched. That library actually turned off some major function. Maybe it's some new Intel CPU bug or something like that, where they turned off some functionality, or the library had some sort of security vulnerability and it has to do something differently. And now it doesn't do what it used to do in the way that it used to do it. And it's not as performant. That's important to know, number one, before you go to production, because you might not be able to make your SLAs when that happens. Number two, lets you look at what's going on under the covers, and maybe you can still get the same throughput that you wanted, but maybe it's a little costlier, or maybe it just requires a different architecture because now this portion of your solution behaves differently. You want to know that, and you want to be able to interact with that information so that you can make the decision, what is the new optimized configuration, because it might be different than what you ran in the previous release. Those are the kinds of things that we want our customers to be enabled to do, and that's the power of what the solution brings to you. And that brings me to the Q&A portion of this.
Awesome. Thank you, Brad. We actually had a few questions already come in, but for those of you, if you do have questions and haven't already asked them, please feel free to use the Q&A section at the bottom of the screen. The first question popped in pretty early on, and it's an easy one, so I'm happy to take this one myself. The question was, is there a trial product that we can access, how and where? Brad, you covered this already pretty extensively, but we do have a free version of our product that allows you to test, automatically optimize your application in production or for production, free for life, as you mentioned. If you're interested in seeing the impact of the product at a larger scale for more applications, we're happy to set you up on a trial or a POC. We'll work with you however you need. The next question that came in through the chat actually was, do you experiment with cloud platforms such as EKS, AKS, or GKS?
Oh, that's a great question. Actually, and I should have covered that in what I was talking about. We run everywhere Kubernetes runs, right? So whether it's on-prem, whether it's in cloud, various flavors of what's in cloud, whether the vendors got control of the control planes, pretty much anywhere that Kubernetes runs, OpenShift, you name it, we run there. Usually for some of those, it may be an RBAC thing where they've locked something down and you might have a slight RBAC change, but that's pretty much it.
Great, thank you. The next question that I'm seeing here is, what is the level of effort for getting up and running?
Level of effort's pretty simple. The real key is that ultimately you have to create your experiment file. So the experiment file is informed by your current application. Your current application has YAML files that describe itself. You have to determine what parameters are you trying to tweak and tune, right? So once you have those, then it's a matter of creating the experiment file to allow you to patch that. And so to give you an example of that, let me go back to the recipes. I'm just going to jump back to a simpler one just so that's easier to explain. In this experiment, we've got parameters that we're tuning, and ultimately down here, this is where we patch those parameters. This is standard Kubernetes patching. This is what happens actually when you're in Kubernetes and you edit an object and change some values and save it. This is what's actually happening in the background. It's creating a patch and then applies this patch change in the background. We're using that same mechanism. So in this case, those pieces of information were in your application YAML file. At this location, which is spec, template, spec, containers, resources, that same path, right? You're just mimicking the path and saying, these are the things that I want to change. That's pretty much it. The other piece that you have to have is a load test. So whatever it is that you test your application with now, most people are doing load tests to verify that the application takes some load. It's whatever scripting maybe your QA team's using to inject data and to use your application in that way. Part of the experiment at the end is, how do we, let me get to an experiment file. That way I can show an experiment. At the end, you either have a container that's doing that testing, or you have a container that is synchronizing and coordinating. If you have external load testing tools or chaos tools that send load or something like that, it allows you to basically control and start and stop, right? So after the experiment, after the the trial is brought up, it's patched to the levels that you want it patched to, you then have to kick off load. You either kick that off inside of a container that's within the environment, and then we spin it up and run the container with whatever arguments that you want to run it with, or you synchronize and use something external like a JMeter or a StormForger or something like that that does load testing. And in doing that, you then are able to push traffic against your application for the period of time or for the amount of data or however you've designed that. And that's how we measure what's going on. So pretty typical, the kinds of things that QA teams and DevOps teams do to make sure that the application is performing the way they would expect. This just gives you that next level, which is, what is the right configuration? The challenge with what you might be running already is, you can measure all that you want to measure about how it runs in in production, but you may not be running the right architecture to begin with. You may not have the right number of replicas. You may not have the right architecture under the covers, and that can make a significant difference in performance and in cost. Hopefully that answered that.
Yeah, the last question that I've seen come in so far, actually another one after this, but the one before it is, does this work in development or production?
This kind of trialing you would do in development or a down level system. You'd want to run it in a down level system closest to your production. Most people have a dev test, but then they usually have a pre-production or something that simulates production as close as possible. Nothing keeps you from running it in production, but this, of course, isn't your actual it's your actual application, but it's not taking all the front end load the way your regular application does. We recommend running it in a down level environment, just so that we're not a noisy neighbor in your environment. If you're trying to test, maybe you're in retail and you're trying to push what Black Friday looks like, right? You don't want that on your production environment beside your regular infrastructure, then taking a bunch of load and becoming a noisy neighbor to what you've got. But there's nothing that keeps you from running it there. It runs in any Kubernetes and runs in its own namespace. So you can run it in the same kinds of environments.
Awesome. The last question that came in was actually just asking for your contact information. So I'm going to type your email address in here for them now. But other than that, thanks for the demonstration and taking the time to walk us through this.
Yeah, you can find me on LinkedIn as well, Brad Askar. As far as I know, I'm the only Brad Askar in LinkedIn, so I'm pretty easy to find.
Awesome. Well, thanks everybody for joining the webinar.